Well, good evening. Good evening. Welcome, everyone. I'm just checking my own cell phone here. So thanks for coming out tonight. And thank you, those of you who posted your response to my question. I appreciate that. I can't wait to look more closely at them. My name is Cecilia Dietrich, and I'm your presenter for the evening. I used to teach art here at the Hill and Plains School in New Milford, but I left about 5 years ago, and now I'm teaching science at a middle school outside of Boston, where I live near Boston. But I love to come back down here to the McCarthy Observatory at least once a year to do this program, and I try to come back other times too when I can. One of the things that I love to do as a teacher is find ways to bring art and science together in my lessons. They just have always seemed like such a natural combination to me. And so towards the end of the program tonight, I'll talk about these astronomy observation journals that I have made for the kids. If parents are really excited about it, you're very welcome to take some. I don't know how many people we'll have this evening. I just want to make sure we end up with enough for the kids that do want them. And they're over in that basket right there, and I have some pencils over there too, because I'm going to show you how you can use these astronomy observation journals as scientists who are curious about light pollution and other things in the night sky. And so, thank you for coming. Our program tonight is about light. I call it Lights On, Stars Gone, with the theme being light pollution. So I'm going to spend the beginning part of this program talking about light pollution and what it is, and then we'll talk about why some of the effects that it has on organisms here on Earth, and then we'll talk about, if you're concerned about it, what you can do to help. But I'm just going to share with you my response to my question that I asked at the beginning, which was, what do I love most about the night sky? I love the stars, and I love seeing the deep sky objects through the telescopes. So when it's hard to see those things, like tonight, because we have clouds, it's a disappointment. I also love the peacefulness that we can feel at night when looking up at the night sky. So, yeah, I know. This just doesn't really even need any comment other than just enjoying it. This is the night sky, obviously, with the Milky Way, and unfortunately many kids in this world are growing up without ever being able to see the Milky Way due to light pollution. Here's another view of the Milky Way. These are images that I've gotten from Wikipedia online, and I have some other images from one of our observatory volunteers who does a lot of imaging. So this is, of course, a picture of our star, our sun, and the question that I ask with this picture is, where are the stars when the sun shines? Can we see them? Anybody ever thought about that? What happens to the stars when the sun is shining? Any guesses where they might be? We can only see one star when the sun is shining during the daytime. What is that one star we can see during the daytime? You know the answer. Yeah. Do you know? You want to tell us? Yeah, the sun. It's our star. Do you think there are other stars out there during the daytime? There sure are. We just can't see them. But why not? Why can't we see the other stars that are in the night sky? Or, sorry, in the daytime sky? Anybody know? Yeah. Oh, thank you. Yes.
Because the light from the sun drowns them out.
Exactly. The light from the sun is too bright for us to see anything else up there. Occasionally, if you know where to look, you might be able to see some bright objects like Venus, but and I've been able to find that during the daytime here at the observatory. It's actually quite exciting to do that. But generally, the brightness of our star, our sun, makes it impossible to see the other things that are in the sky at the time. And of course, this is New York City, lit up at night with a lot of light pollution. So it's the same effect when you have too many lights on at night. It's the same effect as during the daytime. With the sunshine, we can't see the stars. There's probably some clouds in there too that are making it difficult to see the stars. So since my program is really about light pollution, I just wanted to get it out there right now what light pollution is. It's defined as any adverse effect of artificial light, and most people consider that to be a bad thing. But pollution then is anything in the environment that's something harmful or unwanted. So sometimes things like the light during the daytime, we need that. So it's not necessarily always harmful, and there are times when we do need to put lights on at night to help us. So the definition is that light pollution is when it gives us an adverse effect, a harmful effect. So I thought we could start by just looking at different types of pollution. And I think these are all things that you're familiar with. We've got water pollution, air. Unfortunately, we're all familiar with these types of pollution. Light pollution, noise pollution. I live near Logan Airport, and people are always complaining about the noise from the airplanes. But even people who live in cities just have a lot of sound around them all the time. Even soil can become contaminated and polluted. So I put this slide up here, it was in the last slide there, because sometimes the beauty is in the eye of the beholder. Sometimes there are people who think this is a really beautiful thing, and I have to admit that looking at this cityscape, I do see a lot of lovely qualities in this image, but as an astronomer and as someone who knows about the adverse effects of light, too much light at night, I know that this is actually not something that I should be admiring. But, I mean, the colors are beautiful, the patterns and the lights in the buildings and the lines of the beams going up into the sky is really quite lovely. And here's another image of a city at night all lit up that's actually really lovely. But it's artificial light, and we're learning more and more about the harmful effects of too much artificial light at night, not just for the harmful effects for astronomers and people who appreciate the beauty of the night sky, but there are many other creatures and plants on this planet for whom too much light at night is not a good thing. So I want to talk for a few more slides here about what can happen when we have too much light at night and how that can affect what we see at night. This room always gets warm as we've got so many people in here. So the Bordy scale, I learned about this as I was doing research for this, is something that measures a scale that's used to measure the night sky's brightness. So I thought this was a wonderful image that really shows us, number one would be the dark sky, and that's what you would see way over on the left of the slide here. You would see that in dark sky areas, and then this would be what you would see if you were in a city, and everywhere in between. Does anybody have any guesses as to which one of these numbers on the scale might represent what we see here in New Milford? Yes?
A 3 or a 4?
Yeah, I would put it at a 3 or a 4, maybe a 4 or a 5. Depends on what part of New Milford we're in. Anybody have a different idea? Yes? Yeah. Okay. Maybe up in northern New Milford, it might be closer to the 3, but certainly down closer to Danbury with all the lights, it's definitely more into the 5. Yes?
One time I was here, I guess it would be more around the 4. I can almost see the band of Milky Way.
Oh, wow. Great. Yeah, I have definitely seen the Milky Way here, and at night. We're surrounded by light from the office buildings and the school, unfortunately, but I know that the community here has done an awful lot to work with the McCarthy Observatory to mitigate the lighting that they need for the schools and the safety of the property here. So, one of the questions that I used to wonder when I was young was how many stars are there, and that we can see anyway from our planet with our naked eye without aid. And there are computer programs that have tried to figure this out, and basically they think it's around, it depends on what source you're looking at, but basically they're saying that we could see around 8,000 to 9,000 stars in our night sky from the planet Earth. But the fact that, and I see your hands up, so I'll get to you in just a moment, the fact that we could see, once upon a time, we could see thousands of stars on a moonless night, and now there are, as I said, there are kids who are growing up without seeing the stars, and certainly not seeing the Milky Way. And someone in the back had their hands up. Yes?
Yes. I was, maybe instead of 8,000, maybe 8 billion, because it depends on which sector you're looking at. Like, that picture probably shows like 8,000.
Okay.
And if you multiply our whole Earth looking around it, it would probably make up to 8 billion.
You're right. We're talking about the whole sphere of the Earth and the universe around it. Good point. Thank you. Okay. Once again, I actually was, I confess, I was captured, my attention was captured by these images of cityscapes all lit up in colors. I do think there's a beauty to this too, but I definitely prefer the night sky. So one of the things that affects what we can see from the planet Earth with our naked eyes is the dimness of the stars, or magnitude. Astronomers talk about the magnitude of a star. So the brightest stars are a magnitude of 0, or closer to 0. And you can see on this chart here that Venus is a magnitude of even closer to -5. And the full moon, being quite bright there, is around 14, -14. So the higher the number is actually dimmer objects. So the naked eye limit is right here, about, oops, I thought that I would have a cursor up there, but I don't, so never mind. The naked eye limit, you can see, is right there at a magnitude of about 6.5. So that means that even though there's other stars out there, in perfect sky conditions, perfect dark sky conditions, we can only see stars that are as dim as magnitude 6.5. And in cities, we can only see stars that are as dim or as bright as around magnitude, closer to magnitude 0. We can see the full moon in a city because that's really quite bright, but stars have to be very, very bright with a low magnitude in order for us to see them well, especially in the light polluted skies. So there's some people can like to use the Little Dipper, the asterism of the Little Dipper, to gauge the brightness of their sky at night. And of course the Little Dipper is part of Ursa Minor. I have it over there in that image on the left, highlighted. And this is a chart, this black image with the white lines. That's just a chart showing the magnitudes. So can you tell me, what is the brightest star in this asterism here? Remember, the brighter ones have a lower number. Can you tell from there, or are the numbers too small? We're looking for the number that is the smallest number. That would be the brightest star. On here, on this chart. Yeah, you're up in front, you can see.
The top, the magnitude 2.02.
Thank you for your good eyes to see that. Yeah, Polaris with the magnitude 2.02 is the brightest star in this asterism. It's certainly not the brightest star in the night sky, but so hopefully you can see Polaris. But then the dimmest one, are you able to see where the dimmest one is? Yeah?
It's magnitude 6.39.
All right.
It's the magnitude 4.95 and 5.48.
Is that what you guys in the back saw too? Yeah. So if you can see these stars that are down in, oops, okay, well, that's fine. That's the next slide. But if you can see these stars that are kind of down in the bottom of the bowl, all grouped together, then you know that you're in pretty good dark sky territory. If you can't see them, then you know that you're in light polluted sky. So I just tilted this chart so that you could just place it more accurately with the image that's of the actual night sky. So in this Astronomy Observation Journal, there's a page with this chart so that you can make your own comparison with your night sky here or elsewhere. Yes?
I've actually seen the big ball, I think.
Fabulous. I hope you have. I know if you come here to the McCarthy Observatory for the programs and there's no clouds, I know that you can see it. People will be able to show it to you. In fact, when I'm finished talking and you go outside, see if you can look for it. It'll be over in that direction. Okay. So Mark Polanski, who's one of the telescope operators and observatory volunteers here, took this image of M57, I think it was, in 2 locations with the same equipment. So this is way up in Greensboro, Vermont, northern Vermont, almost on the Canadian border, where it's quite dark. It's not totally dark, unfortunately, but it's quite dark compared to Watertown, Connecticut. And he did use some enhancements with the processing, so you wouldn't see this with the naked eye, but he took them with his camera attached to his telescope. But I think you can get the idea that in northern Vermont, there's less light pollution than in Watertown, Connecticut, here, our neighbor. So thank you to Mark for putting that this slide together for me. I appreciate it. And then this is something, just another example of the constellation Orion in dark skies and light polluted skies. I think you're all getting the idea that it's really can be quite dramatic, the limitations of what we can see in light polluted skies. So how light pollution happens. Does anybody want to think about that for a moment and let me know what you think? What causes light pollution? How does it happen? Yeah?
The amount of electricity you use, like turning on and off the lights constantly.
Okay, yeah, so you're talking about 2 kinds of pollution. The energy, the pollution that comes from generating the energy, but also the lights themselves. Yeah. So the lights are on, and we do put a lot of lights on in some places at night. And you can see from this picture here, this is the same house, the same community. It was taken, this image was taken in before and after in 2003, the Northeast blackout. It was taken in Toronto. This was something I found on Wikipedia too. And you can see during the blackout, I think that house has a generator to put some lights on, but the effect of eliminating the lights in the neighborhood was dramatic. All of a sudden you could see the Milky Way. So why do we light up our nights? Any ideas? Why do we put lights on at night? Why don't we just keep them all off if we're agreeing tonight here that light pollution is not such a good thing? Yeah? Why do we put lights on? Yeah, okay, to help us feel more secure. For sure. Yes?
So we can see?
So we can see where we're going. Absolutely. There's obstacles. There's like Legos on the floor and and rocks outside that you might trip on. Yeah?
We need the light, so yes, obviously we can see, but also we can navigate our way, because if the only things that we can see is we can clearly see in the dark, but when it's like nighttime, we can't really. And there's also if you're trying to find someone, it's basically, what do we call it, a silhouette.
Yeah, a silhouette. That's
yes.
yeah. You just have to know the shape of your friend or your mom or dad.
Yes, or else it's just a random person on the phone.
Did someone else have an idea? I saw another hand. Oh, okay. Yeah. I think we're okay.
I was gonna say a little of the same thing.
Oh, okay. Did you want to add anything more to what he said? Or no? Okay, he covered it. All right. Thank you. So, yeah, I think we're all in agreement that we do need some lights. I mean, it's helpful to have some lights on at night for safety and for comfort. And in fact, that is really why we put lights on at night. But for all of human existence up until the last 100 years, we did not have the benefit of lights at night. So it's really changed. Having nighttime lights has really changed the way that we interact with the world. What did you want to say in the back? Yeah?
I just want to say, when there were no lights invented, they actually had to use fire.
You're right. They had to use fires like a torch or something, or just stay around the campfire, or hope for a night with a full moon. Have you ever noticed how when you go outside on a night with the full moon, you can see a lot more because of the reflected light? Yeah. So lights at night are not always bad, but what's bad about them is when there's too much that we don't really need. So this chart, or this diagram I got from the darksky.org. It's the International Dark Sky Association. Has a lot of information about the harmful effects of light pollution and what you can do to help prevent it. And this diagram, I thought, really illustrates well all of the extra light that escapes from what is otherwise a good intention. I mean, it's a good idea in this case to have a street light so that cars can see where they're going. But you can see that this light, this lamp that's not well made, not well designed, is wasting a large amount of light energy that didn't need to be spent. So the boy in the back who was talking about the electricity to turn lights on and off, you can see that this light could really be functioning with probably half the electricity than is being used, because all that extra light there outside of that bright cone is really kind of wasted. So it's always a good idea to look around your own community too, in your own home. And this, I'll show you this slide again a little bit later, but it shows you what good lighting looks like at night and what the very bad lighting looks like. basically, if you can just think about lighting up the area and only the area that needs to be lit at night, your safety will be increased because you won't have glare, like blinding lights. When you start to be drivers, driving at night, you'll understand that sometimes the headlights make it hard for you to see where you're going, even though it's light. Yes?
I know how like this is how like the very bad
Yeah.
and then best because the very bad it's like going everywhere and
Yes.
it's just wasting so much.
Mm-hmm.
But in the bad one it's not wasting a lot.
Yeah.
It's just wasting a lot because just the top is covered up.
Yes, exactly.
And then the middle is just a little more covered, and then the rest is very covered.
So
it's just pointing down in like a triangle.
So you've already identified the importance of shielding light so that it only is directed, it only goes to the place where you need it to go. Because we certainly don't need that whole big sphere, that whole big globe of light in the very bad section. We don't need to light up the night sky. We just need to light up the area where we're going to be walking or driving. So I found this fact to be, or this statement to be an interesting one to consider, that more than 80% of humans live in areas of light pollution. This next map oops, I'm sorry, it went too fast. Oh, I switched my slides around and I didn't even realize it. Okay, this is fine. So this is from NASA, this image. I think it really highlights so clearly the areas in the world where we have a lot of light on at night. This is satellite imagery versus the areas in the world where there's no lights and you would be likely to see the perfect dark skies. Where would you have to go to see really dark skies, truly dark skies like people 100 years ago saw? Where would you have to go? Yeah? Up to the top in the polar regions? Yeah? Where else? Yeah? Yep, in the areas in Africa, sure.
Parts of South America and Australia.
Yeah, so there's this part up here in Brazil where the Amazon is, the Amazon River, and then of course down here in Antarctica as well. It's dark there. But what do you think all these places have in common? Why would there be these few places spread around the globe with no lights on at night? Yeah?
They have people and houses, and those houses have electrical systems, and those electrical systems have light.
I would agree with that statement. Yeah. You want to add to that? Yeah?
No, I'm just going to ask about something
Oh,
else.
okay, sure.
In like a show, I seen like this part, and all the lights in Japan were like off.
Oh, okay. That was probably when there was a disaster that prevented where all the electrical grid was off.
There was like this,
Yeah.
thing,
Yeah.
and then they did a lot of
Yeah, that's a whole other topic. We'll have to talk about that another time. But no, that you're right. I'm glad that you pointed that out because, you know, Puerto Rico right now is still suffering from with a lack of electricity from the hurricane, and satellite images of Puerto Rico before and after the hurricane really show exactly what you're talking about. You saw in Japan, lights on and lights off. Oh, yes?
That could be another political thing. You look at North and South Korea, the difference.
Yeah, there is so much that could be inferred from just this map with no information. Yeah. Yes?
Do you know what the two lights are riding out of gas car in the ocean?
I don't know specifically. It could be small islands, because I know there's some small islands over there, but I also know that there are places that are lit up in the ocean because the fishing fleets need lights to catch their their catch, their fish, at night, and they purposely will light up the ocean. So that might be part of what's going on. It's surprisingly visible from in satellite images, the fishing fleets. So this is another interesting map that on the chart on the top left there shows the degrees of light pollution. And I'm going to get a little bit closer up on that. This is the United States. And you can see that if we wanted to get dark skies here in the United States, we would really have to go out to the far west. It's kind of a hopeless situation here on the Northeast. We do have some dark skies up in the Adirondacks and upstate New York and upstate Vermont and New Hampshire, but it's pretty bright where we are. A lot of people here on the Northeast turning on all their electricity. So I just put this back in here because we were looking at the light pollution maps. And this is, well, actually, let me ask you if you can tell what this is. Anybody have any idea what this map is about? Yes?
The amount of light and electrical production, like where humans mostly put their light in houses.
It's definitely about light and the amount of light in the night sky. Does anybody recognize this area? You think you know where that is? It's right here. The white here is New York City, but this central X or cross right in the center of the map, that is New Milford. This map is from an image that you can get to from the McCarthy Observatory. Oh, and you know what? I thought this was going to work. I was all fancy here, and it's not working, so never mind. This was a link. It was supposed to link to the McCarthy Observatory. I was going to show you how to find this, but instead it went back. Anyway, technical stuff. Doesn't matter. This is, you can look for it in the McCarthy Observatory. Go to the link that takes you to the weather, and you can find the light pollution link there. There's a little bit of dark skies, but not much. And this just shows you a little bit better. Same map, but with the cities on it. And this blue up here is upstate New York. And I'm going to continue on. That was, I'm sorry, I'll just tell you that the New World Atlas of Artificial Sky Brightness is where these images came from. So if you're curious to see other locations, just look for that, the New World Sky Atlas.
Is New York the brightest place in the world? New York
That's
City?
a good question. I mean, it certainly looks like it's...
Based on data.
I haven't looked at the data that closely, but based on my observations, I would say yes. Certainly in the Northeast, yeah.
So we're in trouble.
Yeah, oh yeah, we are. Yeah. So who's affected by light pollution? And I see that, as usual, I've been talking a lot, so I'm starting to run over my time. So I'm going to kind of go through this part a little bit more quickly than I wanted to. But basically, all living things on Earth are affected by light pollution. All organisms. And the reason why we're all affected by light pollution is because all living things on this planet evolved over millennia in a light and a dark cycle. So that means that our bodies, our cells, our DNA require the light-dark cycle in order to function well in ways that we actually are only just beginning to understand. In fact, the Nobel Prize was just awarded for the research on the circadian rhythm, which is just what I'm talking about, the need for that light-dark cycle. So, I mean, lightning bugs need dark in order to be able to signal for their mates. Predators need the darkness in order to be able to hunt well. Even baby hatching sea turtles get confused when they see the lights on the shore. They need to go to the water, but they see the lights on, you know, up the beach a little bit, and they go towards that. So everyone is affected by this, and we just need to be aware of that as we're making decisions about light in our environment. So the International Dark Sky Association has this statement that plants and animals depend on Earth's daily cycle of light and dark rhythm to govern life-sustaining behaviors such as reproduction, nourishment, sleep, and protection from predators. So what can we do to help? We can, and again, this is information from the International Dark Sky Association, and their website is down on the bottom there, darksky.org. But the first thing to do is just look around your neighborhood and your home. Look at your home and see where the light is escaping that's not necessary to be there. Think about energy-saving features, timers and dimmers on your outdoor lights, and make sure that they're shielded, like in that image that we saw. We want to have the light directed only where we need it. And then, you know, you're coming here tonight is great, but start to talk about this with your elected officials, with community members. Talk about the problems of light pollution. So just to remind you, look at your own lights, and this is the last thing that I'm going to tell you. So I hope you can take this journal here. Just one moment, let me explain this, and then I'll answer some questions. So this is a Astronomy Observation Journal with a number of different pages. Here are two that are specifically about light pollution, and I'm encouraging you to measure the light pollution in your own environment. And on this page here that's on the right, you can measure it in location A and location B and make a comparison. So choose two different places, perhaps here at the McCarthy Observatory, and then if you're fortunate enough to go to a vacation in the mountains or elsewhere, or even just in northern Litchfield County one night as you're driving someplace else, take a look out at the window and see if you can see a difference. So I'm not going to explain all the pages. There's instructions, and I encourage you to read them and have some fun with this. And if you ever think about bringing it back, I'd love to see what people do with these journals that I hand out each time. But so that's the end of my presentation. I don't want to make the people outside wait too long, but are there are some questions. Yes?
Is there a distance that light pollution travels? Where it crosses into an area that really doesn't have many lights on it?
Yeah, I don't quite know how to answer that question because I didn't do any research on that, but I'm just thinking about how there's different types of lighting, and some are more bright. I mean, there's definitely headlights that have a brighter lights that travel farther. I'm thinking of laser lights that travel quite far. So I think it just depends on the type of lighting that it is and the design of the lights. Yeah.
Curvature of the Earth sometimes has an effect on it too. Like
Okay.
light pollution will be more so spread out up in the sky, where the curvature of the Earth
Yeah.
lowers that effect of it on the ground.
Yeah. Yeah, that's a good point also. So, just a second. Yes?
How far can light pollution travel?
It can travel as far as like a light beam can travel. So it depends on how strong your light is. Do you have a flashlight that you can use at home? Yeah, try that out. Check that out. Take the flashlight and go outside in the dark if you're allowed to. And then just see if you can like shine the flashlight on something in the distance and figure out how far away that is. And then see if you can shine the flashlight on something even farther. And that'll give you an idea of the answer to that question. Okay? Yes?
And your what's being affected is like our food, like also by like nightshades and things like that.
Well, okay, our food, to the best of my knowledge, our food is affected because the pollinators get confused. I didn't even know this until I started doing the research. There's nighttime pollinators and there's daytime pollinators. So the daytime pollinators, they're okay, I think. But the nighttime pollinators, there have been studies that show that they get very confused when they're trying to pollinate a field that's got light pollution from nearby buildings. and for a variety of reasons. Yeah. There's probably more things going on too, but I'm not aware of it. So, thank you so much, and thanks for coming out tonight, and I hope you enjoy the rest of the evening. Thank you.